Here we see the maximum amount of hydrogen bonds water can make, and it's really up to 4, but we depicted our diagram off of this diagram, which I'll talk about in a second. So water is I'll start with water is polar because it shares electrons, but it doesn't share electrons equally, making it polar. And so we can see it has up to 4 hydrogen bonds that it can make. And water is cohesive because it's polar, so they want to grab onto as much water molecules as they can, and we can see that all here, all the hydrogen bonding. Okay, since water is polar, it has a lot of hydrogen bonds going on, which makes it cohesive, which creates a lot of surface tension, so it makes things not go through water so easily, especially like things like this staple.
As you can see, the water's hydrogen bonding makes the water molecule structure have a negative side and a positive side, meaning that the water molecule is polar. And as you can see, because the water is in a sphere while it's dripping on the coin, it has cohesive properties as the water stays together while on the coin. And as you can see, that's 21 drops. As you can see for the oil, unlike water, oil's hydrogen bondings makes the molecule nonpolar, which is different from water's polar structure. However, similar to water, it also has cohesion bonds. As you can see, as it drips down into the coin, it stays together in a sphere similar to water. However, it took 25 droplets for it to spill, unlike water where it took 21. Maybe that is because water is polar, meanwhile oil is non-polar, so that means oil takes more droplets for it to spill.
So we added pepper to our solution. Well, not solution, it's just water. And as you can see, water is polar, and since it's polar, a lot of hydrogen bonding is happening and it makes water cohesive, and that cohesion causes a lot of surface tension upon water. So that's why when you saw the pepper floated on water, and on that toothpick we put in soap, and then when you add soap to water, it lowers the surface tension of the water, and you can see the pepper like going to the bottom, and pepper is hydrophobic, so it won't dissolve in water or anything.
So water, right? Water molecules, they are covalently bonded, meaning they have slightly positive and negative charges, which is why it's polar, right? That's why it's polar. And so
And what does this diagram show?
This shows when water is a solid, right? As you can see, it is tightly compact, which means its density is very high. As it has a higher mass and low volume. It has a low volume actually. So when you start heating it up, it changes states, so it becomes a liquid and slides around.
Beautiful.
And this means the density decreases because what does it do with the hydrogen bonding?
Keep going.
Yes.
You're doing so good. Kendall, you tripped him up. Okay, keep going, Lay.
And when you heat it up even further, right? It's going everywhere, dude. It's going everywhere.
And what does this show?
So the gas shows the
And
change
this
of
is the
states.
gas?
Yeah, it changes states from liquid to solid. To gas.
And what happens to the density?
The density is very low.
Is that all you got? Polar, meaning that it has a lot of hydrogen bonding going on. Ice is very dense, so when ice is put into water, it melts and goes into a liquid, which lowers the density. And since water has a high surface tension because it is cohesive, ice floats. Yes.
So because water has hydrogen bonding, That means the water molecule is polar. The one part of the molecule is positive, while the other part is a negative. So you can see the water going down the string. The reason why it's sticking down to the string is because it has adhesion properties, meaning it sticks to other surfaces. But at the same time, it also has cohesion properties because all the water is staying together. So as he keeps pulling the water down, it sticks on the string due to adhesion properties, and the water stays together due to cohesion.
Okay, so you can see like he's pouring in salt into a test tube filled with water. And so salt is polar, it is ionic, it is an ionic compound, so when water and salt are mixed together, they dissolve into, salt dissolves in water because a polar dissolves in a polar. And this creates a solvent, and salt is also hydrophilic because it is polar, so polars dissolve in polar and salt dissolves in water.
Alright, so as you can see, water is polar, meanwhile the oil is non-polar, meaning that the oil is hydrophobic, which means it doesn't dissolve in water. As you can see, it's staying on the top, which is why you're seeing the oil stay on the top.
Right here, water is polar, you know what I'm saying? So when you heat up the water, right, you can see that it's like bubbling, and you can see like the condensation happening at the top of the glass. That means it's the water is boiling and it's exceeding its heat capacity.
Had water is the top droplet, and ethanol is a lower droplet. So you can see that both of these substances, water and ethanol, is polar, but water has a cohesive property, so you can see water is staying as one droplet, and ethanol is kind of like spreading out, and it spread it out like all over the table, and so that's why it does that. And the heat capacity of water and ethanol are very different. Ethanol has a low heat capacity, especially compared to water. So it is on my left, and ethanol has dried up on the table, but water has a very high heat capacity. So it hasn't dried out even when we spread it around on the table.